This is the general block diagram showing the overview of the work that is being done. This is the clock and it is a synchronous circuit. It is working every time at the clock tick. So the input is declared as a clock. Here there are different functions which are called module in case of Verilog. These modules define the gates. AND gate has input and output, two inputs and one output. It is assigned to perform the AND gate operation. This operator performs AND operation. Similarly, this function or module is a OR gate. It has again input and output, and this operator performs the OR operation between the two input variables AB. Similarly, other gates are defined. Now the third module, the third function we have defined is overall function gates. In here we have generally two inputs, then we will select between the gates and there will be output and a clock that will run the whole schematic synchronously. These are the output lines. Now we are creating instances. This is the inputs A and B of the AND gate, and this U1 is the instance of the general A input. Similarly, Y, which was defined as an output for all, is general, and output variable is now mapped to the output. So this will be selected. Now how will we select the output? We will select the output by defining a select variable. So this input variable will be mapped to a toggle switch. These three combinations on the toggle switch will allow us to select one of the gates and perform one of its operation. Now one important thing is, what is A and B? A and B is input. In the constraints file, A and B is tied to the onboard slide switches. So I will show you those. These are the onboard slide switches labeled as 10. These two switches, switch 0 and switch 1, will be A and B. This will be A, this will be B, and this LED will be your output. And these three toggle switches will act as select multiplexer select line. So 0, 0, 0 will select AND gate. How am I knowing this? Look in the programming. 0, 0, 0 will select AND gate and connect it to output LED. So if I double click the select gets the output of AND gate and maps it to LED. So LED is the word that we need to write in the constraint file. Here it is written inside the curly braces. So you replace the general name here and replace it with the variable you have named in your design module. Onboard LED, just one LED is being used. Where is it connected? It is connected to G1 pin. Now in the diagram, you know, G1 pin, can you see here? G1 pin is this. This pin is connecting to LED number 0. This is LED number 1. We are using LED number 0. Where is LED number 1? I have deleted all the other entries. I am using only the file that is needed. Now I have given you the link of the file, the constraint file for Boolean board. When you are making the project, you will have to read the FPGA chip that you have, the board specifications, and then you have to select those specifications. When you select the correct specifications, then only you will be able to create a correct bit stream and burn it onto. We'll go on to that part, burning part, later, but first I'm explaining the code. Now I'll continue. So XDC file is constraint file. This file maps to your hardware. So clock input is defined here. This is the input according to which the clock, according to the clock, synchronously everything will, at every clock, these assignments, everything will happen. Every clock it will be refreshed. This assignment will be checked at every clock cycle. 100 megahertz is the clock for this FPGA device. Now AB are input. Select line will be mapped to pin number L1, K2 and K1. Where are they? They should be here, K1, K2 and L1. These toggle switches have pins L1, L2 connected, and we have named them as select lines. So register select holds some binary data. Select is a register. It is defined somewhere here as input. It holds 3-bit data, 0, 1, 2, 3, 0, 1 and 2, 3-bit register. It holds these 3-bit numbers. And when you toggle the switch, when you will toggle this switch up and down according to one of these fashions, suppose 0, 0, 0, I will show you practically running this on a camera. I will attach later, but I am explaining here that when this happens, then AND gate will be checked by toggling AB. So let us go to the simulation. Sorry, the practical part. Now you can see a screen on your in this video. I have made available a screen. This screen will help you to recognize what is happening. So I will continue with the programming the device. I will go and generate bit stream. Since I have already generated the bit stream, I pressed this and bit stream is complete. So I will open the target. First I will switch on the target. Now the light is on, it is responding. Now I will try to connect the USB cable, make connection through USB cable. USB cable should be plugged into the programmable UART port, and I will press the auto connect button. Now it is trying to connect to the server using this USB cable. When this connection finishes, here message will be updated, and now it is ready. It is showing that this is the device that is connected, and I can now program the device. I have my files ready here, and now I'll just press the program device. These files are design files. Bitstream was generated, and when I press the program device, that .bit file, this is .v file, the module, this is .xdc file, the constraint file, and this is bit file that was generated after I pressed this one. So this takes time. Now we have integrated it to perform the operation easily using a multiplexer method. So program it. There programming has happened. Now here we can test our implementation. Now this is our key. If I have all zeros, so these are all zeros, you can see when these are all lowered down, these are all zeros means their AND gate operation will happen. If I put A high, no light will be on, because 0 1 doesn't mean on for AND gate. AND gate both have to be on, so both are 1 is received. Single one is 1, other is off, nothing is received. So this is AND gate operation verified. Now I will target this one, 0 0 1. So 0 0 1. This will make it OR gate. A single 1 at the input or a double 1, both up, or any single one down, will make the light on, and when they are both off, it is off. So this is OR gate operation using the select lines 0 0 1. Now I will change it to 0 1 0. So this is 0 1 0. On 0 1 0, it will operate as a NOT gate. So NOT gate is when it is down, off, then it is on, the light is on, and it is on, toggling it up on, the light is off. So this is NOT gate operation. Now I will use another code. I will use the last code, which is XNOR. So I will put both these one, and again this is performing XNOR operation. So these are the select lines, these 3 are the select lines, these 2 are the input AB lines, and this LED is connected to the Y output, which is the LED output, selected output. And this is how this project can be tested on the FPGA board. Remember not to plug in here. Plug the USB B type cable here, and have a good image handy, and you can have this all these things on the web page. It is available. So this is the web page of RealDigital Boolean board, and you can download the files from here. if you go here, there is one more link from where you can download the files. You try searching for it, somewhere it is there. I have saved the link also. Urbana board is also available, but we are concerned. So here we go with the resources. On the resources, click on this and you will be able to download the constraint file. So there it is. This is the constraint file you should use. This file you should use. I have deleted the other entries. I have only used the entry. Suppose LED. अब यहाँ पे you have to be careful. You have to write the name of the variable inside the curly braces. So this will be replaced. And here if we go close this program and see the schematic shows this is AND gate, this is OR gate, these are AB inputs, all inputs are AB. This is the select line. This select line will select one of the gates output, AND gate, OR gate, NOT, XOR, XNOR, and clock is universally applied to all, so it is a synchronous circuit. Every clock circuit the output will be regenerated. So this LED is the output. This is, I think, sufficient for you to implement this, and on these lines you can implement all other aims. This is one example of experiment number 1.